Tired. Did that. One equals one. Boolean.
Boolean-based SQL injection refers to the response we receive from our injection attempts, which could be a true/false, yes/no, on/off, 1/0 or any response that can only have two outcomes.
Oh, that's Boolean.
That outcome confirms that our SQL injection payload was either successful or not. On the first inspection, you may feel like this limited response can't provide much information. Still, with just these two responses, it's possible to enumerate a whole database structure and contents. Practical: on level 3 of the SQL injection examples machine, you're presented with a mock browser with the following URL, HTTP URL. The browser body contains taken true. This API endpoint replicates a common feature found on many sign-up forms, which checks whether a username has already been registered to prompt the user to choose a different username. Because the taken value is set to true, we can assume the username admin is already registered. We can confirm this by changing the username in the mock browser's address bar from admin to admin123, and upon pressing enter, you'll see the value taken has now changed to false. The SQL query that is processed looks like the following.
I wasn't paying attention. I was thinking about what's on you. I'm tired. I'm so fucking tired.
The browser body contains taken true. This API endpoint replicates a common feature found on many sign-up forms, which checks whether a username has already been registered to prompt the user to choose a different username. Because the taken value is set to true, we can assume the username admin is already registered. We can confirm this by changing the username in the mock browser's address bar from admin to admin123, and upon pressing enter, you'll see the value taken has now changed to false.
Yep.
The only input we have control over is the username in the query string, and we'll have to use this to perform our SQL injection. Keeping the username as admin123, we can start appending to this to try and make the database confirm true things, changing the state of the taken field from false to true. Like in previous levels, our first task is to establish the number of columns in the user's table, which we can achieve by using the union statement. Change the username value to the following.
Oh. Okay. I fucked up. It's probably confused on that. Hmm. Taking true.
As the web application has responded with the value taken as false, we can confirm this is the incorrect value of columns. Keep on adding more columns until we have a taken value of true. You can confirm that the answer is 3 columns by setting the username to the below value.
Yeah, that makes it true.
Now that our number of columns has been established, we can work on the enumeration of the database. Our first task is to discover the database name. We can do this by using the built-in database method and then using the like operator to try and find results that will return a true status. Try the below username value and see what happens. We get a true response because, in the like operator, we just have the value of %, which will match anything as it's the wildcard value. If we change the wildcard operator to a %, you'll see the response goes back to false, which confirms that the database name does not begin with the letter A. We can cycle through all the letters, numbers, and characters such as, and underscore until we discover a match. If you send the below as the username value, you'll receive a true response that confirms the database name begins with the letter S.
Huh.
Now you move on to the next character of the database name until you find another true response, for example, SA%, SB%, SC%, etc. Keep on with this process until you discover all the characters of the database name, which is SCLI_3. We've established the database name, which we can now use to enumerate table names using a similar method by utilizing the information_schema database. Try setting the username to the following value.
Or I'm not typing that now. That I'm just gonna read and then paste. From different schema tables.
This query looks for results in the information_schema database in the tables table where the database name matches SCLI_3, and the table name begins with the letter A. As the above query results in a false response, we can confirm that there are no tables in the SCLI_3 database that begin with the letter A. Like previously, you'll need to cycle through letters, numbers, and characters until you find a positive match. You'll finally end up discovering a table in the SCLI_3 database named users, which you can confirm by running the following username payload.
So the database name is SQL3 and the table name is user. So we use that. I should get a true.
Lastly, we now need to enumerate the column names in the users table so we can properly search it for login credentials. Again, we can use the information_schema database and the information we've already gained to query it for column names. Using the payload below, we search the columns table where the database is equal to SCLI_3, the table name is users, and the column name begins with the letter A.
I wonder. I wonder. So I'll start with an A. Starts with an I. So column name starts with an I.
Again, you'll need to cycle through letters, numbers, and characters until you find a match. As you're looking for multiple results, you'll have to add this to your payload each time you find a new column name to avoid discovering the same one. For example, once you've found the column named ID, you'll append that to your original payload, as seen below.
This is kind of a lot to know. What the username and password was that? not case sensitive, I think. It's not. What am I doing wrong? Oh. This is fucking hard. Oh, you motherfucker. Logged me out.
Time-based A time-based blind SQL injection is very similar to the above Boolean-based one in that the same requests are sent, but there is no visual indicator of your queries being wrong or right this time. Instead, your indicator of a correct query is based on the time the query takes to complete. This time delay is introduced using built-in methods such as sleep, x, alongside the union statement. The sleep method will only ever get executed upon.
It's fun. God, it's hard, man. This one's really hard. I just don't understand databases and SQL a lot.
A time-based blind SQL injection is very similar to the above Boolean-based one in that the same requests are sent, but there is no visual indicator of your queries being wrong or right this time. Instead, Your indicator of a correct query is based on the time the query takes to complete. This time delay is introduced using built-in methods such as sleep, x, alongside the union statement. The sleep method will only ever get executed upon a successful union select statement. So, for example, when trying to establish the number of columns in a table, you would use the following query.
God damn it, mean. I'm talking to an AI. It worked. It's instant. S. What was the last one? It was SQL something. Would it be SQL 4? Okay. 2 from damn it. Stop fucking with me. Is that not it? Oh man, this is hard. that so long? I mean, I'm almost there. Okay, I'm confused of what I need to do. What? Why is there never a walkthrough on that? There's no fucking walkthrough. There we go. There's a fucking walkthrough right there. That's all I was needing. So we need to change it. So the thing is to change it to admin. not giving me. It's not delaying. God damn it. It's not fucking. I'm not understanding what I'm doing wrong. There's a delay on that one. But it's not giving me a delay. I don't know. I'm not understanding why I can't get a delay on that. I'm gonna do this one again.
Out-of-band SQL injection isn't as common as it either depends on specific features being enabled on the database server or the web application's business logic, which makes some kind of external network call based on the results from an SQL query. An out-of-band attack is classified by having two different communication channels, one to launch the attack and the other to gather the results. For example, the attack channel could be a web request, and the data gathering channel could be monitoring HTTP/DNS requests made to a service you control. 1. An attacker makes a request to a website vulnerable to SQL injection with an injection payload. 2. The website makes an SQL query to the database, which also passes the hacker's payload. 3. The payload contains a request which forces an HTTP request back to the hacker's machine containing data from the database.
Oh, that was hard.
Remediation. As impactful as SQL injection vulnerabilities are, developers do have a way to protect their web applications from them by following the advice below. Prepared statements. With parameterized queries in a prepared query, the first thing a developer writes is the SQL query. And then any user inputs are added as parameters afterwards. Writing prepared statements ensures the SQL code structure doesn't change and the database can distinguish between the query and the data. As a benefit, it also makes your code look much cleaner and easier to read. Input validation. Input validation can go a long way to protecting what gets put into an SQL query. Employing an allow list can restrict input to only certain strings, or a string replacement method in the programming language can filter the characters you wish to allow or disallow. Escaping user input. Allowing user input containing characters such as $/ can cause SQL queries to break or, even worse, as we've learned, open them up for injection attacks. Escaping user input is the method of prep-ending a \\, to these characters, which then causes them to be parsed just as a regular string and not a special character.
That was pretty hard. I'm gonna do that one again another day. That was pretty crazy. Yeah, I want to do that one again. But burp sweep, we're gonna do that tomorrow. Burp sweep. What's in here? Repeater, intruder, other module. I feel like I'm doing that anyways. Alright, guys, well, I'll see y'all tomorrow. I might play some Battlefield.